This problem is going to involve the Pythagorean theorem. So the Pythagorean theorem says if you have a right triangle labeled A, B, and then the long side called the hypotenuse is C, then A squared plus B squared equals C squared. All right, so Justine wants to put a deck in the corner of her backyard in the shape of a right triangle. So here's the corner of the backyard, and this is the deck. Anyway, and it's a right triangle. I put my right angle right there. The length of one side of the deck is 7 feet more than the other side. So one side is x, and the other side is x plus 7. The hypotenuse is 13. I'm assuming 13 feet. I typed these out of the book. Okay, find the lengths of the two sides of the deck. So now you have like an A and a B and a C. You've got all the parts of the triangle labeled. So we're going to use this Pythagorean theorem. We'll say this is like the A, this is like the B, and you have to, it doesn't matter which one's A and which one's B, but the C has to be at the long one, the hypotenuse. Okay, so A squared plus B squared equals C squared. For us, that's going to be x squared plus, now you have to write this as x plus 7 squared equals 13 squared. All right, so now we have an equation, and we're going to get, it's going to be a quadratic equation, and we get to solve it. So multiplying out the x plus 7, you can go over to the side if you want and write x plus 7 times x plus 7. I'll just do this real quick. X squared plus 7x plus 7x plus 49. X squared plus 14x plus 49. Okay, so that's going to go in right here. All right, so I've got x squared plus x squared plus 14x plus 49 equals, and then I have to know 13 squared, it's 169. Okay. Now we're going to get combine like terms. So x squared plus x squared is 2x squared plus 14x plus 49. And let's go ahead and bring over the minus 169 because we know we're going to have to set it to 0. So let's just bring that over. You don't have to. You could do it in 2 steps. Okay, so we get 2x squared plus 14x minus 120. All right, now it looks like I can factor out a 2. So I'm going to do that. GCF, oh, we'll slip on the computer there. The GCF is 2. So then I get x squared plus 7x minus 60. So now I need to think of 2 numbers that multiply to be negative 60 and add to be 7. I'm not coming up with them right off the top of my head. Probably should, but I'll just write them out. So 1 times 60, 2 times 30, 3 times 20. I think we made this list earlier. 4 times 15, 5 times 12. It's that one. Okay. 5 and 12, and 6 times 10 if you want to finish it. Okay, we need one of them to be negative. It's going to be negative on the 5, so that's the combination right there. Now this 2, you can divide both sides by 2. You're allowed. You can divide by both sides by whatever number you want as long as it's not 0. So we just get rid of those 2's. And we could have done that before when we had a problem like this. I just like to explain it a little bit more. Okay. But the 2 doesn't, it's not going to affect our answer. Okay, this factors into x minus 5 and x plus 12. So again, you can say, well, x minus 5 equals 0, or x equals 5. And the other one, you'd have x plus 12 equals 0, or x equals negative 12. But remember what x is. X is this side of the triangle, so it can't be negative. So we're going to throw this case out, and we'll stick with the 5. So one side of the triangle, or the deck, one side is 5 feet, and the other side, okay, way back up there, we can scroll back up, but it was 7 feet more, right? So the other side is 12. Now, at this point, or 12 feet, I should say. At this point, you might say, oh, well, see, that was a negative 12, so it's going to be a positive 12 in the answer. That doesn't always work. It depends on the problem. So try not to jump to any conclusions because it might backfire on you later on. But for this one, we get 5 feet for the one side of the triangle and 12 feet for the other side of the triangle. It doesn't say